Okay, let me start my video and share my screen. So thank you very much. So Eric, hey, great job going through the manifesto. It was awesome. And I love the quote, work without fear or heroism. And I want to put a management corollary on that, work without blame. And so like you, Eric, I started my career as a software engineer. And I worked for about 15 years writing code at places like NASA and Microsoft and MIT. And then at about 2005, I went into the data and analytics field and I managed people. And, for about 5 or 7 years, basically my life sucked. I had data scientists and data engineers and people who did data viz at work for me. And as a manager, when your life sucks, it's really tempting to blame people, to find someone and say, it's their fault, it's not my fault. And I don't know if you've ever experienced this as an individual contributor, as a manager. And so what I started to do was read this guy named Dr. Deming, and he said 94% of causes were common cause. That means it's not a person's fault, it's the system that people work in is the fault. And as a leader, I took that to heart, and it actually made me reflect on how much I sucked as a leader and how much I needed to change, but also really how much I hadn't built a system for people to be successful. And when the data was late or wrong, when customers wanted a follow-up question and we couldn't answer it, or when my team wanted to use a different tool, all those things that made my life suck, I realized I hadn't built a system. And so that's the kind of the theory of data ops in another way, is that what you do is much less important than how you do it. So a lot of times we spend thinking about, how do I build a cool model, or what's the algorithm? What kind of data transformation am I going to do? How am I going to visualize that? How am I going to governance, even the data itself? And these things, these processes, the system that works and builds these things, development, deployment, monitoring, iterating, collaborating, measuring, is actually more important in some ways than the thing that you're doing. And so this really contrarian perspective, the tools, the technology, the data is actually less important than the system that is to do that. The machine that makes the machine is more important than the machine itself. And that's a really different idea. And so what does that mean, really? Well, if you look at it and you think about the process and think about all that stuff that goes with it, what actually do you want to do? And I think from a data ops idea, you want to focus on decreasing the cycle time at which you can get ideas from people on your team through their keyboard into the eyes of your customer, and then iterate and improve. The other part is you want to decrease the amount of time you go into work with dread in the morning because something broke, or you're worried something's going to break. So lowering your error rates. And then the third thing is you just want to not have so many meetings and just forget all the bureaucracy. Let people innovate and find a way for people to collaborate quickly and easily. And then the last part is you need to measure your process. If you're going to be data-driven about, you want your customers to be data-driven, you should be data-driven about your work. And so what that looks like in reality is that most people today have a cycle time, and we did a survey with Eckerson last year of months to change an analytic, or weeks. It takes 20 lines of SQL. Some companies takes them 4 months to go from dev to production. Some companies, I've talked to companies who are very proud that they're down to only one major data error a month. Which seems crazy to me. I've talked to many teams where the self-service group hates the internal IT group, the internal IT group hates the data science group. And most teams I've talked to haven't even begun to measure their process. And we've sort of backed this up with some surveys from Eckerson. And the result of that is actually, it's more expensive to do your work, and your customers are unhappy. And so by kind of operating and focusing on these 4 levers and kind of moving them all up at once and following these sort of data ops principles of focusing on cycle time and error rates, which is kind of a superset of data quality, collaboration across people and tools and environments, and measuring results, you can have, I think, a better chance of success. And so what I'm going to talk about is kind of how we do that in 3 examples. And so one of the cases that I'm going to give a simple example, and this is sort of what Eric talked about, is the first thing is there's a factory that you run, and the factory is data goes in one side and artifacts created from that data go out. And you've got a lot of tools. In fact, there's hundreds of tools to do data and analytics, from databases to data pipeline tools like Airflow, to data science tools, to data viz tools, to data catalog tools. And you want to run this factory like Toyota runs a factory, low errors. You want it to, if someone's going wrong, you want to be able to fix it and think about how to improve it. And I think that's really important because most people have lots of these factories all over the place. And these factories themselves are kind of owned by different organizations. And so how those teams interrelate is actually kind of hard in data and analytics. In software, dev and ops is sort of one-to-one. Data ops is sort of one-to-many in terms of many people are developing and many groups are doing production or operations. And then finally, analytics is code. And so you need to have a process to take the code from the team development environment and get into production. And you got to do all this sort of crazy stuff at the same time. You got to run a nice Toyota factory, produce really, really high quality deliverables, or else your customers are going to not trust the data. And then when they ask you follow-up questions, you've got to very quickly get those into production. And then you've also got to make sure that you do this across this complicated set of teams. And so being able to do all these things at once is a mark of a best-in-class organization. And it's very similar to the book that Eric brought up at the end, Accelerate, which talked about DevOps. And one point of that book is best-in-class teams are able to do lots of things well at the same time. And in fact, trying to do all those things together at the same time actually was a good idea. So it's not a trade-off to say, I can only have low errors, but I got to go slow. I can only have good collaboration, but it's got to be, I can't have any measurement. So let's give 4 examples of what customers did. So if you talk about, you talk about the why do data ops? Well, the business problems they're trying to solve are, first of all, I can't deploy stuff from dev to production, it's taking months, or my customers don't trust the data because it's wrong often, or my self-service BI team thinks my centralized IT team is a bunch of idiots. And so these business problems are where people focus on trying to get value from data ops first. And the idea here, again, comes from manufacturing. If you apply the theory of constraints, find one of these things, fix it first, and then iterate and improve, find the bottleneck. And this comes up in books from manufacturing, books in general, books from software. And so let's take an example of European Telecom. And so they had a big system centralized on an Oracle data warehouse. They had lots of other tools sitting on top of that Oracle data warehouse, data science, data visualization tools, but it took them 4 months to move something from development to production because they had sort of 4 environments: a development environment, a test, a UAT, pre-prod, and then EDW. And they had a very manual process to move things from one environment to the other. They had no way of knowing if things worked when they moved it from one environment to the other. And so they had just had a lot of meetings. And so whether it was 1 line of code or 1 Informatica job or 20, it all was pretty slow. And so the first idea is that you need to abstract the environments that you work in. And so it makes it easy for you to move things from one place to the other. And so having everything in source code, having a sense of that your environment from your dev environment to your QA, that you can move things and automate things with a button click from one to the other is important. And then second, you need to prove when you're in an environment that things work. And so what you need is tests, and tests are like what software engineers do. Regression tests, functional tests, and a lot of people just do a unit test on a small piece of code, and that's just not enough. You need to have tests across the whole end-to-end system. And we've got a whole bunch of ways to think about that, and location balance test and historic balance tests, ways to actually prove that the entire system works in one environment. And then as you move it, and maybe you've changed 1 thing or 20 things, you can prove that it works. And so that way, those 2 keys of abstracting the environment and automating testing and deployment are a way to go fast and improve deployment speed. So the second example, as I plow through, is too many errors. And so in this case, this company has, they've got this really complicated environment. They've got NiFi and Kafka. They've got, vehicles that are streaming, vehicles that are going and giving information in batch. It goes to Oracle and notebooks and Tableau. They've got some cloud going on. This is owned by different people. And they had no idea if one of these vehicles started to give or a whole set of vehicles started to give bad data. It only showed up in the for the data customers. The customers were actually doing the QA. They would say, hey, something looks weird. And then everyone would have to run around trying to figure out what the problem is. And so what we did is we actually built what we call a recipe on top of it that abstracts that whole environment, that monitors it, that observes it, that digs in and finds out, is the data correct? Has the data changed in a large way from the last time we saw it? And then sends alerts out if something's wrong. And you can see this complicated graph here. It's like, it's got Oracle and NiFi and Kafka and MLflow and Tableau, and it's just Spark. It's a whole lot of things that are going on. But you need to prove to yourself that things are working before your customers do it. And the best way to do that is creating tests and monitors and alerts. So the last case I'm going to talk about here is a top 5 bank. And so there's been a big trend to do self-service analytics. And so a lot of cool tools like Tableau and Looker and things like Alteryx. And so they've got a lot of users, and they want to build sort of a data sandbox or a data and analytics sandbox for 1,000 IT users. And really to help both with compliance and fear of these people actually using the data in the wrong way. And so, the example here is that the centralized IT team had a whole diverse set of people to support. Maybe someone in Brooklyn who does small business loans, or Texas that does high net worth, or branch banking in the Northwest. And they actually all have different sort of needs. The New York business person needs data for the last 24 months, and then Tableau. The Texas person needs a database in Python and SQL access. The Seattle person needs Power BI access. So provisioning data and the tools on that data, and then monitoring what happens is an important part for compliance reasons, is an important part of it. And so we built a system that allows them to solve these kind of challenges of who has access, how do you monitor it. And we did it by kind of working and following a business process they set up, having a request form, and then being able to build out a kitchen and recipes to support that. And so those 3 aspects are really the one of the keys. And so all these customers, I think, just to finish up here, at least had a sense that you can do all these things. You can go fast, you can have low errors, you can improve collaboration, and you can measure. And the results of that is that you actually do lower cost and lower your number of unhappy customers. And so you kind of can do it all with DataOps. And again, it comes from a focus not on the cool new algorithm or I need to buy a new database. It comes from focusing on these sort of process things, decreasing cycle time, lowering error rates, improving collaboration. And we have a software company, obviously want you to buy our software, but you can start today with very simple things. Like one thing I did in 2007 was I created something called a quality circle. And I had a spreadsheet. And every time we had an error in production or a customer was upset, I made another row in the spreadsheet. And then every 3 weeks, we sat around with all the people involved and we looked at the spreadsheet and said, well, what can we fix? What can we improve? And this quality circle, we just picked one a month. And you know what? After a year, we started to have a lot less errors. And so, the way that you can help collaboration is use Git. It's free. Testing is a big thing. So you can start your DataOps journey today with the tools you have and using things just like Excel or spreadsheets. And if you want to accelerate your journey to there, well, of course, we have a software platform that does that helps you directly address all these things and can get you there quicker. And like Eric, we wrote a book. We wrote the manifesto and have a lot of resources to help you on your DataOps journey. So that's it for my presentation.
Thank you so much, Chris, and Eric as well. So let me remind people that if you have questions, you could put those into the Q&A box or put them into chat. Either way, I'll be monitoring those and taking a look. But I had a question for both of you. What happens in the DataOps world when the company you're dealing with is the result of a merger, which seems to be the way businesses are going these days? There's tons of companies deciding to merge. And how does that affect the DataOps situation?
Well, why don't I take a shot at it, then maybe Eric gets done. I think that's merging is a special case of the fact that lots of people own the data value chain. And so, in some organizations, even pre-merger, you may have a centralized team owning data and a decentralized team owning the visualization of the data. And when you have a merger, you may have another team that owns the data and another team that owns the visualization. So how you rationalize that and how you actually make sure that as you transition something from one system to another, how you have those teams work together, I think having an even playing field and something that's tested and monitored and deployable with DataOps makes it a lot easier to help integrate systems. Because if you're gonna, in a merger, a lot of times it's, who gets to win? Yeah. Which data warehouse wins? But in the meantime, you've already got two things running. How do you keep them both running and make sure that as you merge something from one system to the other, it is exactly the same? And so that's to me, it's about the fact that you've got a multi-team world, and how do you handle that?
Eric?
Yeah, and I would 100% agree with that. And I would add on, I've been in this situation a couple of years ago where our client was a large hotel chain that had just merged with another large hotel chain. And that was part of what I was doing, was trying to merge those things. And we definitely were in a situation where, unfortunately, what I thought was the better data warehouse did not win, but that is okay. We still definitely really had to work on, again, a lot of those collaborative and really understand the data and kind of just work from there. And still a lot of code driven, a lot of, making sure, do we have a full understanding of both sides, grab what we can from the one that we thought won, and if not, at least map it nicely and, quickly get that mapping out there to say, hey, did we agree with this? Okay, now let's start implementing it versus just implement it, move it over. We still had that artifact out there and traced it over time when we were wrong and just kind of started, going down the chain.
You were wrong? What?
Yep. Very easy to do.
I've got another question here. What are your thoughts on DataOps principles applied to systems where data is collected from sensors to cloud, which involves multiple platforms, including embedded systems? You want me to read that one again?
Yeah.
There's a lot in there. Let me read it one more time because there's a lot in here. What are your thoughts on DataOps principles applied to systems where data is collected from sensors to cloud, which involves multiple platforms, including embedded systems?
So to me, the DataOps principles are invariant of this data size, big or small data, invariant of data speed, and invariant of data type. And so whether it's unstructured or structured, or big or small, or whether it comes in tiny bits from a million places or in one big bit from another places, you're still having a set of principles to help you focus on error rates and deployment. And I think the other complexity that comes with having embedded systems is similar to the fact that, let's say you have a software development team who has a transactional app that has a database, and they make a change to it and add some columns to that database for their web-based app. And you're the reporting team. And so they've got some new data for you in their database. So how does that rollout of those new columns in the database for your transactional application go with your data warehouse, your reports, your models that build on it? And so there is a linkage between the process of deploying transactional code, whether it's on a website or in an embedded device, and your analytics from it. And so I think a team that runs a DevOps process and continuously deploys can work with a team that runs a DataOps process that continuously deploys.
Yeah, I would agree with that as well. Having kind of done a lot of different variations of things in the wild, I feel like this is almost the same problem as when you run into on-premises things, except that it runs way faster and there's a lot more data, but the principles are still the same. You have disparate environments that's kind of really just, you handle it differently, but at the end of the day, if you treat them all as the data is the data, the processing is code, you treat it, you move it on, you get it out. Yeah, it shouldn't matter. That example where things like containers and some of the other modern tools we have really come into play is you can pretend to be one of those Internet of Things systems, ramp it up on a cloud environment, pretend. We have a lot of event hubs, things like that exist in from an engineering standpoint. But yeah, the actual principles, I agree with Chris, are the same. You should be able to pivot pretty quickly.
Okay, all right. So here's a question specifically for you, Eric. how can we apply DataOps principles to R&D projects?
That is a very good question. So what I would say with that is, and I'm kind of seeing some of my data scientist friends kind of come up with this idea of ML ops, and I think it overlaps a lot with data ops. And in general, the idea being is that you still have to do research in that sense. And even though it may not be, it's a quote unquote throwaway thing, or it's a, we know this is not, it's a prototype, it's, and I'm actually doing some of this right now. I would still say it applies. Just treat what you are developing is still production. In some cases, if you're lucky, you still have the ability to, you might actually be lucky enough to have control of, we know what we're trying to collect. And to borrow from a colleague of mine, she calls it a primary data project versus secondary, where you don't.
Oh, yeah.
I always thought it was a great term. So essentially that could be the case, but in general, I would say, again, the principles shouldn't hugely be different. You should be able to apply them. You're still starting on a basis. You can still iterate, recognize it is R&D. You're probably still focusing towards some specific goal, even if it's not a repeatable production process. I would still say break it down to small increments, still use that same general idea of whatever you are creating is production, whatever your prototype is. Even if you have several throwaway prototypes, you can still, assuming it's like a machine learning project, create a model that you think is good enough, put it out there, go ahead and deploy it, get some feedback on it, cycle, because I'm assuming an R&D project usually has a good time frame of 1 to 2 years.
Yeah,
Sure. Like
that. Yeah. Chris, did you want to add anything?
No, that was a fantastic answer.
Okay.
Perfect.
We have one more question here that would probably take several hours to answer, and we only have a few minutes. Is there a best practice to deal with the security of data where data is required to be cleansed and shipped outside of the company due to an outsourcing model development?
Yeah, I think there's an emerging field called data SecOps, data security operations, and there's some companies focused on that. And I think that's a case not only when you have data that you're giving to partners, but also is when you're having test data that you're using for development. Because in some cases, you don't want to have your developers access to people's social security numbers, credit card numbers, but those attributes are in production. And so the process of building test data sets or sharing data means applying a set of data privacy rules to it and make sure that those are tracked and measured. And companies, there's several companies that are focused on that, and we've partnered with one of them. But I do think it's an important part in thinking of data security. And I think there's other aspects. There's we're going to have a speaker in one of our company's webinars talk about data governance ops. Yeah. And being able to say, because let's say you have a table, right? You want to make sure that table isn't, if you're going to allow people to look at it, maybe they don't have rights to the table. Maybe they shouldn't see every column in that table. And maybe when you deploy it, you should actually have a data dictionary that's available. Good points. Thinking of it as a whole process of security, governance, visualization, that sort of end to end is in the scope of what we're trying to do with DataOps.